All right, Algebra 2, moving on with logarithms. Apparently today is the most important property of logarithms. Everything else we've done to this point hasn't been very important. I'm making fun. It's all important, right? A little reminder, in yesterday's lesson, you guys discovered the logarithmic property. I'll just write it down. Oh, that's not plus. I'll write it down correctly. Times x equals k plus log x. Okay? It's a special way to look at the additive property of logs. So this is what we're going to work through today. This is log x plus log y. Okay? So let's review a little bit of what we did yesterday. We're going to use this little logarithmic table and calculate some specified logarithms by splitting them up like we did yesterday. So we can look at log of 80 and say that's the same as log 10 to the first power, or times, sorry, I did it again, times 8, which is 1 plus log 8, which we'll see right there, is 0.9031. So we have an answer here of 1.9031. Same thing here. This gives me log 10 to the third power times 7, which is 3 plus log 7 is 0.8451. So that gives me 3.8451. Last one on this page. There's a few more on the next page. Log 10 to the negative 1, 2, 3, 4, 5 times 6 equals negative 5 plus log 6 is 0.7782, which gives us negative 4.2218. Okay, you guys try these two on your own. I know you can do it. All right, there you go. Okay, so like I said 2 slides ago, we know that log 10 to the k times x is equal to k plus log x. And we've got these handy dandy tables of log of 1 through 9 to help us find the answers to these problems. Another little review, okay? This is just to get our brains working. What is the log of 10 to the k? Well, remember, if we don't have anything written there, it's a 10. So we would say 10 to the what power equals 10 to the k. Our question mark equals k. So this answer is k. What is another way we can write the formula? Log 10 to the k times x equals, that's a times. We've been writing it like this, but what else can we say? How else can we write it? Well, we can say that this is equal to log 10 to the k plus log x. And this works great when we have a 10 here because we know that our answer is k. But what if we don't have a 10 here? Okay, what if, because when our bases are equal, when these two numbers are equal, that is what our value is. But if these two numbers aren't equal, then we're going to have to do a little bit more work, and that's what we're getting to today. So let's use our calculator to complete the following table. All right, so you're just going to take log 10, log 12, log 16, etc. All right, and I'm going to copy and paste it in there for you. So go ahead and write them down because we're going to need them, so I need you to write them down, and I'll be right back. Doesn't that look awesomely professional? All right, we're going to use this though, and I'm not going to have the chart on every page after this. So write these down, make sure you have them to 4 decimal places, and I'll show you where they go as we work through the calculations. So I have log 2, which if I go to the table, it is 0.3010, and log 4, which is 0.6021. That equals, handy dandy calculator. I don't need a calculator for that one. That one's easy. Sorry. 0.9031 approximately, because we've rounded everything. And if you look, that is approximately log 8. And what do we see? Not telling you yet. Keep looking for the pattern. We have log 2, same number, plus log 6, looking it up on the chart. 0.7782, 3010 plus 0.7782, oh goodness, sorry, try again. 0.3010 plus 0.7782, I get 1.0792, 1.0792. What does that look like on your chart? Hey, it looks a lot like log 12. I wonder how we got 12. Okay, log 3, looking at my chart, 0.4771 plus log 4, 0.6021, that gives me 2,789, 7, 1 point, this is what I get for trying to do math backwards, 1.0792, which looks a lot like log 12. How do we get log 12 again? Oof. You guys try these 3 on your own. I'll be right back. Alright, your answers should be pretty darn similar. And I hope you have seen a little bit of a pattern. Alright. Alright, what patterns can you see in exercise 2 in the table from exercise 1? Write it using logarithmic notation. So what we saw was what I alluded to early in the lesson. Log of xy is the same as log x plus log y. What pattern would you expect to find for log x squared? Well, log x squared is the same as log x times x, which should be the same as log, oh for goodness sakes, log of x plus log of x. Okay, it's 2 of them, right? You could verify that just looking at log 4, which should be equal to log of 2 plus log of 2, right? Very cool. Make a conjecture for a logarithm of the form log xyz, where xyz are positive and real numbers. Well, it's going to be the same as what we've done. So log of xyz is equal to log of x plus log of y plus log of z. And that's how it's going to work. Okay? You could check that with things like log of 18, which would be the same as, what, log of 2 plus log of 3 plus log of 3. Because 2 times 3 is 6 times 3 is 18. Things like that. All right, let's try it with some real numbers. Use the logarithm table from exercise 1 to approximate the following logarithms. So here I've got log of 14. That's going to be the same as log of 2 plus log of 7. So go ahead and look it up. Log of 2 is 0.3010 and log of 7 is 0.8451. So log of 14 is approximately 1.1461. 35, you're breaking these into really prime numbers. So 35 is going to be the same as 5 and 7. So log 5 is 0. And I'm just going back to that chart. I have that chart sitting right in front of me. Plus 0.8451. So log of 35 is approximately, Okay, you go ahead and try the next few. I'm going to push pause. Okay, there's C. If you look at D, 121 only breaks into 11 times 11. But if you look at the table, I don't have a value for log 11. So I can't figure that one out, can I? Bummer. All right, use your calculator to complete the following table. Round the logarithms to 4 decimal places. Okay, go ahead and do some. I'm going to copy and paste the answers in here because it's really hard to write in these itty-bitty little boxes. All right, we're going to use this table for the next set of exercises, so make sure you have them written down, okay, because we're going to need them. I realize it's a little blurry now. That's a bummer. We can still read it, though. What do we see here from our pattern? Log of 2, log of 1/2. It looks like it just went negative. 4, 1/4, negative. It looks like they're all going negative, like 5 and 1/5, etc. That's pretty cool. Why is that? Let's look at it. What patterns do you see in the table from exercise 6? What is your conjecture using logarithmic notation? Well, it looks like for any number, x is greater than 0, the log of 1/x is equal to the negative of log x. Every single one of them, right? So use the definition of logarithm to justify the conjecture. Well, I can say if log of 1/x equals a, then 10 to the n equals 1/x. What is n? Then 10 to the negative n equals x. Therefore, we must look at log x equals negative a. Or, with what we're doing, log of 1/x equals negative log x. And that'll make total sense with a few practice problems. Cool? Let's do the practice problems. All right, I'm going to do 1 or 2, and you're going to do 1 or 2. Let's try to break this one up. Use the logarithm tables and the rules we discovered to estimate to 4 decimal places. So I can break this one up to log of 10 to the 2nd power times 21. So that would give me 2 plus log 21. I don't like 21 though, right? That's more like 3 times 7. I need more space. So that gives me, I'm going to look up 3 and I'm going to look up 7. Log 3 is 4771, and log 7 is 0.8451. So that means that log of 2100 is 3.3222. Estimation, right? That should be squiggly. Okay, let's try B. I'm going to do B in blue because I'm going to run into spaces on things. So here we have log 10 to the negative 5th times 49. And this one's going to be 7 times 7, right? So I have negative 5 plus log 7, which is 0.8451 plus log 7. That gives me negative 3.3098. Okay, why don't you try these next 2, and we'll check our answers together at the end. So go try them on your own. All right, go ahead and push pause and check those out. Make sure they make sense to you, because that's the end of the lesson, and if it doesn't make sense to you, it's going to be hard to figure out what to do. All right, but I thought this lesson was a lot of fun. I hope you think so too. There's your lesson summary. It's what we did. Good job.